Very, very important question. It can be the question, it can be root 5 or root 2 or root 3 or root 7 or root 8, etc. etc. HCF means highest common factor, that is 2 into 1, 3 into 1. One is the HCF. What is 91? 91 can be 7 into 13. Here the highest common factor is 13. Therefore, HCF is equal to 13. First you factorize 510. How we can factorize it? With 2. 510 with 2, that is equal to 255. Hi dear children. Today we are going to start our first chapter, real numbers. Already we know about the real numbers. Lower classes already we have studied it. Okay. Some important points to remember in this chapter. First, we are going to discuss the important points in this chapter. That is HCF. First one is HCF. What is HCF? HCF means highest common factor. In lower classes already we have studied it. HCF of AB into LCM. What is LCM? Lowest common multiple. HCF of AB. A and B are any two numbers. HCF of AB into LCM of AB is equal to A into B. What is its meaning? The meaning is, suppose A and B are two numbers. HCF of AB into LCM of AB, that is equal to product of these numbers. Suppose the numbers are 2, 3. Suppose the numbers are 2, 3. What is its HCF? HCF means highest common factor, that is 2 into 1, 3 into 1. 1 is the HCF, highest common factor. HCF is, here HCF is equal to 1. What is LCM? LCM is, both are prime numbers. For prime numbers, LCM is product of the numbers, that is equal to 2 into 3, that is 6, right? That is HCF into LCM is equal to, what is it? 1 into 6, that is 6. Similarly, the product of the numbers, product of 2, 3, that is equal to 2 into 3 again 6. That is HCF into LCM is same as the product of the given numbers. That is this rule. And we get two more equations from this equation. What is it? HCF of AB is equal to, take LCM of AB into right hand side, that is A into B divided by LCM of AB. Similarly, what is LCM? Take HCF of AB into right hand side, that will be lying on the denominator, A into B divided by HCF of AB. HCF of AB is equal to 1, a pool where A and B are co-prime integers. Co-prime integers means here 2 and 3 are the co-prime integers, and 3, 4 is also a co-prime integers. That means the highest common factor of 3 and 4 is 1. Such numbers are called co-prime numbers. Co-prime numbers includes a non-prime number, that is not a problem. But 3, 4, if we consider 3 and 4, the highest common factor is 1. So we can say that it is a co-prime integer. Okay, right? But 4 is a non-prime integer, 3 is a prime number, but 3, 4 is a co-prime integers. Okay. Next is, what is a natural number? It is usually denoted by n. The natural number is usually denoted by n. Natural numbers are also called counting numbers. The numbers which are used for counting. The numbers are 1, 2, 3, 4, etc., which are used to counting, are called natural numbers. It is denoted by capital N. In mathematical notation is the collection of the integers 1, 2, 3, 4. The collection is denoted as 1, 2, 3, 4, etc. This is the collection. It is sometimes called set. It is read as set. Set means collection. Set of the digits 1, 2, 3, set of the integers 1, 2, 3, 4, etc. That is, in the starting number, first number is 1, but it consists infinite number of numbers. Okay, that is n is equal to 1, 2, 3, 4, etc. This is called natural system of natural numbers, system of counting numbers. Okay, already you have studied in your lower classes. And if we, what is the next statement? If we add the number 0 to the collection, that means 0, 1, 2, 3, 4, etc. If we add 0 to the collection of natural numbers, then this system, this is called whole number system, whole number. It is usually denoted by W. Whole number. What is a whole number? Whole number, the complete elements of or complete integers of natural number plus 0. One more digit, 0. This is called a whole number. It is usually denoted by W. If we add the number 0 to the system of natural numbers, then it becomes the system of whole numbers. It is denoted by W. Okay. It is denoted by W. And what is next? The natural numbers are also called positive integers. What is positive integers? The natural numbers are also called positive integers. This is a number line 0, 1, 2, 3, etc. Here it is minus 1, minus 2, etc. This is minus infinity. This is plus infinity. The natural numbers are also called, that is starting from 1, 1, 2, 3, etc. are also called positive integers, right? The collection of all positive integers, 0 and negative integers, that is called set of or collection of or group of integers. It is usually denoted by Z or I. It is usually denoted by Z. Z or I used to represent collection of integers. How we can write it? Etc. minus 2, minus 1, 0, 1, 2, 3, etc. infinity, or this is minus infinity, this is plus infinity. Okay. These integers are called integers. That means integers consist negative integers, 0 and positive integers. The integer 0 is neither positive nor negative. Integer 0 is neither positive nor negative. 0 is neither positive nor negative. Okay. Zero is neither positive nor negative. And integers, the notation of integers, that is capital Z or capital I. We can use both, no problem. But natural numbers are used capital N only. Used capital N only. Whole numbers, capital W. Okay, right? The next is rational number. What is a rational number? What is a rational number? Rational number means the numbers which can be expressed in the form P by Q, where Q not equal to 0, P and Q belongs to Z or I. This form is a rational number. The numbers of the form P by Q, where Q not equal to 0, that means the denominator cannot be 0, right? But P and Q belongs to Z or I. That means integers. It can be positive, it can be negative. Okay, right? For example, 2 by 3, minus 3 by 4, minus 3 by 5, 0, why? 0 we can write it as 1 by 0. 0 is a rational number. What is 4? 4 we can represent as 4 by 1. Then 1 is not equal to 0. So 4 is a rational number, etc., etc. are called rational numbers. Okay, where another example, some 1 by 4 or some 2 by negative 5 or minus 2 by 5, both are same. Okay, these are called rational. Any number which can be expressed in the form P by Q, where Q not equal to 0, P and Q not belongs to Z, P and Q belongs to Z or I, but Q not equal to 0, right? This is a rational number. This is not a rational number. It is not a rational number because here this is Q. Q is equal to 0. What is the definition of a natural number? Q cannot be 0. Q not equal to 0. P by Q is called a rational number, right? Okay. In fact, every integer of Z is also a rational number. Another very important result. Every integers, for example, negative 1 is a rational number also. Why? What is the reason? This can be negative 1 by 1. Negative 2 is a rational number. Why? This can be minus 2 by 1. 10 is a rational number. Why? This can be 10 by 1. Okay, right? So every integers also a rational number. Okay. Next is irrational number. What is an irrational number? One more case. Rational numbers are usually, to represent rational numbers, usually denoted by the letter capital Q. Capital Q in mathematics. Capital Q in mathematics in number system used to represent rational numbers. Okay, right? Then, if a number is not a rational number, then we can say that it is an irrational number. It is an irrational number. What is an irrational number? Suppose the number, it is not a rational number, then only one more possibility, that is an irrational number. For example, root 2, root 2, root 3, root 5, root 4 is not, it is a rational number because root 4 is 2, and root 6, root 7, root 8, root 9 is not, it is a rational number, root 10, these are called irrational numbers. Okay, then our chapter is real numbers. Then what is a real number? Already we have studied natural numbers, whole numbers, integers, rational numbers, and irrational number. Then what is a real number? Real number means the collection of, the group of, the set of rational and irrational numbers, both includes in a real number system. In a real number system, the collection of all the rational numbers and all the irrational numbers forms the system of real numbers. It is usually denoted by the letter capital R. Capital R in mathematics, in number system, it is used to represent the real numbers. Okay, the real numbers includes irrational numbers and rational numbers. Okay, right. Then what is next concept? Divisibility. Already you have studied in your lower classes divisibility, divisible by, you heard about it. A non-zero integer a is said to divide an integer b. That is, or b is said to be divisible by a, or b is said to be multiple of a. B is said to be multiple of a. If there exists an integer c such that b equal to ac, b equal to AC, or B by A equal to C. We can represent like this. B equal to AC, or we can take A into left hand side, B by A equal to C, where A not equal to 0. For example, 8 by, for example, 8 by 4 equal to 2. This is called divisibility. 8 by 4 equal to 2, or 8 is equal to 2 into 4. That means 8 is represented as a multiple of 2, or 8 can be represented as a multiple of 4. Both are same, no problem. Okay, that is the meaning of this sentence. A non-zero integer A is said to divide an integer B, or B is said to be divisible by A, or we can say that B is said to be a multiple of A. All are same, multiple of A, if there exists an integer C, small c, such that B equal to AC. For example, what is B equal to AC? Then B by A equal to C. For example, if 8 by 4 is equal to 2, we can represent it as, when we cross multiply 4 into right hand side, 8 is equal to, that is 2 into 4, that is multiple of 2, right? Another example, again, example, 27 is equal to 3 into 9, right? Here, what is B? B equal to 27. In the place of B is equal to 27. What is A equal to 3 with what is C? C is equal to 9. That is 27 is equal to multiple of 3. And another example, B equal to 24 is divisible by A is equal to 8 with C is equal to 3. Why? What is the reason? 24 by 8 is equal to 3. 24 by 8 is equal to 3. Or 24 is equal to multiple of 8 or multiple of 3, like that. Okay, this is called divisibility. Okay, and the most important part of this chapter is the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Already we have studied it in different forms. The fundamental theorem of arithmetic is related with the factorization of natural numbers, right? The fundamental theorem of arithmetic is related with the factorization of arithmetic, natural numbers. It states that every composite number can be factorized as a product of primes uniquely, apart from the order in which the prime factors occur. That means, suppose we can represent 24 is what is a composite number? Composite number means except one and the same number, at least one factor is exists. Prime numbers means one and the same, only the same number is a factor. For example, 2 is a prime number. 2 is a prime number. What is the properties of 2? 2 is a prime number. 2 is the least prime number. The only even prime number is 2. Okay, 2 is a prime number and 3 is another prime number. For 2, what are the factors of 2? 2, the same number 2 and 1 only. What are the factors of 3? 1 and the same number 3 only. But 4 is not a prime number. Why? The factors of 4, 1, 2, 4. It is a composite number. It is a composite number. Okay. The fundamental theorem of arithmetic states that every composite number can be factorized as a product of prime numbers. So we can write 4 can be 2 into 2. This is the fundamental theorem of arithmetic. Another example, 6. 6 can be 2 into 3, prime factors. Okay. What is 10? 10 is a composite number that can be 2 into 5. Okay. Then what is 24? 24 can be 2 into 2 into 2 into 3. 2 into 2, 4. 4 into 2, 8. 8 into 3, 24. The product of prime factors here. 2 and 3 are primes, prime numbers. So these are the prime factors of 24. What is 50? 2 into 5 into 5. 2 into 5, 10. 10 into 5, 50. That means it is a product of prime factor. Every composite number can be expressed as a product of prime numbers. That is called fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Look, 100. You take 100. We can express it as this composite number 100 into prime factors, product of prime factors. How? 100. The method is, first you take the lowest prime number, that is 2. Check with 2. If it is possible to divide with 2, you can divide it. If it is not possible, check the next prime number. Okay, but here it is possible to divide 2 with 100, that is 50. Okay, right? When the 100 is divided with 2, we get again 2, that is 25. 25. Now, again, 2 is not possible, 3 is not possible. Then, next prime number is 5. Yes, 5, it is possible. 5, 5. So, 100 can be 2 into 2 into 5 into 5. This is the product of prime factors. Again, I can give another example. Express 170 into product of prime factors. How we can represent it? 170. 170. Is it possible with 2? Yes, it is possible. That is 2 in 17, 8 times. Reminder, 2 into 8, 16. Reminder is 1. 1 carry on here. What is then 10? 10 divided with 2, that is 5. Here it is an odd number. Last digit is 5. So with 2 it is not possible. Is it possible with 3? 3. 2 times 25. It is not possible. Then try with 5. Yes, it is possible. 8 1 time. Reminder 3. 35. 35 7 times. But 17 is a prime number. 17 is a prime number. So we can express this as 2 into 5 into 17. 170 is, now the 170 is expressed as the product of the prime factors of 2, 5, 17. 2 into 5 into 17, right? So this is called fundamental theorem of arithmetic. This is the most important part of this chapter. We will do some more examples from your textbook. Okay. Express, the question, express. Textbook question from textbook. Express each number as a product of its prime number. NCERT exercise 1.1. NCERT exercise in your textbook. NCERT exercise 1.1. Express, first question. Express each number as a product of prime numbers, prime factors. First question 140. Second question 156. Third question 3825. Or we can try for these 3 questions. Similar questions are again in your books. You can practice it, no problem. What is the first question? 140. 140. How we can express it? 140. Yes, first you try for with the first prime number, that is 2. That is 70. Yes, it is possible. Again with 2, 35. Again 2 is not possible, 3 is not possible. Again with 5 it is possible. 5 with 17 with 7. 5 into 7 is 35. So we can express the 140 as 2 into 5 into 7. This is the method. So we can write it as again 140 is equal to 2 into 2. 2 square into 5 into 7. This is the final answer. Okay, right? Another question, 156. Second question, 156. 156. How we can express it 150. Try with the lowest prime number, that is 2. 2 is the least prime number. What are the properties of 2? 2 is the least prime number and the only even prime number, that is 2. Okay, all other prime numbers are odd numbers. 3 is an odd number. 5, the prime number 5 is an odd number. The prime number 7 is an odd number. The next prime number 11, it is an odd number. The prime number 13 is an odd number, etc., etc., etc. Okay, right? Only 2, the even number 2 is the only even prime number, right? So try with 2. That is 7 times 1 remainder 68. Again it is an even number, or try with 2. That is 39. 39 is a prime number. 39, it is possible with 2? No. It is possible with 3? Yes, it is 3. Check it. 3 in 3, 3. Yes. But 13 is a prime number. So we can write 156 as 2 into 3 into 13. That is 2 square into 3 into 13. This is the final answer. 156. 2 square into 3 into 13. Try for next number. Try for next. What is the next number? 3825. 3825. Since it is an odd number, we can't divide with 2. So there is no use for to check with 2. So take the next number 3. Yes, it can be divided with 3. What is the sum of the digit is the multiple of 3. So it is possible with 3. With 3, 3, 1. In 2, 3, 2 times. 22, 3, 7 times. That is again reminder 115, 5 times. 1, 2, 7. And again 1 plus 2 plus 7 plus 5. That is again multiple of 3. So it is again it can be divided with 3. That is in total 3, 4 times. In 7, 3, 2 times. 15, 5 times. Again it is divided with 3. 4 plus 2, 6 plus 5, 11. It is not possible with 3. So next, try for next prime number 5. It is possible because this 3-digit number end with 5. So it can be divided with 5. That is 42, 8 times. In 42, 8 times. Reminder 2, 25, 5 times. Again it is divided with 5. That is out of 8. In 8, 5 with 1. The reminder 3, 35. That is 7. 7, it is a prime number. 17, it is a prime number. So this is the how we can express. This is the product of 3 into 3 into 5 into 5 into 17. That is 3 into 3 can be 3 square. 5 into 5 can be 5 square into 7. This is the final answer. This is the final answer. Okay. We can do one more question. Then we will get a clear idea about it. We can take a larger number, 7429. 7429. 7429. Check it. 7429. Since it is an odd number, we can't try with 2. It is not, there is no use for try with 2. What about 3? 3. It is not possible. What about 5? No, possible. What about 7? 7, 74. It is not possible. 11. 11 not possible. 13. 13 how much times? Okay, 17. 17. Try with 17. 1774 4 times. 1774 4 times. Then 3 times. Then 7. 437. 17 into 437 is 7429. Again, not divisible but with 3, 5, 7, 11, 17. 737 is the multiple of 19. Check for 19. That is 19 into 23. Yes, 19. 19 out 20, 43 2 times. Then again 3 times, correct. So this is equal to 17 into 19 into 23. 17 into 19 into 23. This is the answer. Okay. Another question. You write the question. Find the LCM. Find the LCM and HCF. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the two numbers. Product of the two numbers. Question 26. Question 26 and 91. Question 26 and 91. How we can find out LCM and HCF? 26. First we are going to try for HCF. HCF. Factorize 26. That is 2 into 13. Prime factors. You write, use this theorem. You write it as product of prime factors. 26 can be 2 into 13. And what is 91? What is 91? 91 can be 7 into 13. Here the highest common factor is 13. Therefore, HCF is equal to 13. HCF is equal to 13. HCF is equal to 13. Then what is LCM? HCF is equal to highest common factor is here 2 into 13, 7 to 13, that is 13. Then next for find LCM. How we can find out LCM? LCM. LCM is 26, 91. Like this. There is the x plus dash prime factors. X plus dash prime factors. We can divide with it, that is 13, comma, this is 91. Again with 13, this can be 1, this can be 7. This can be 7. Therefore, LCM is equal to 2 into 13 into 7. This is LCM. So this is equal to 26 into 7. 26 into 7 is the LCM. That is equal to 182. 182 is the LCM. HCF is 13. 182 is the LCM. This is the answer for the first part. The second part, check whether, verify that LCM into HCF is the product of the two numbers. The product of two numbers. So, what is LCM into HCF? LCM into HCF is equal to, what is HCF? 13. 13 into 182. LCM into HCF is equal to 13 into 182. That is equal to 2366. When we multiply, you will get 2366. And product of, what are the product of numbers? Product of numbers is equal to, what are the given numbers? 26 into 91. The given numbers are 26 into 91. 26 into 91 is we get 2366 again. 2366 again. So it is correct. Verified. LCM into HCF is equal to product of the given numbers. It is verified. Okay. And another question. And another question. 510, second question. Numbers are 5, 1, 0 and 92. Numbers are 5, 1, 0 and 92. Question is same. What's the question? Find the LCM and HCF of the pair of integers 5, 1, 0 and 92, and verify that LCM into HCF is equal to product of these two numbers. Okay. How we can find out the HCF of 510? First you factorize it. First you factorize 510. How we can factorize it? With 2. 510 with 2, that is equal to 255. 255. Again with 3. 3 is possible. 3, 8, 5. Then with 5. 5 with 17. Okay. 510. 510 is equal to 2 into 3 into 5 into 17. Again factorize 92. 92 with 2, that is 46. Again with 2, that is 23. 2 into 23. 92 is equal to 2 into 23. The highest, so the HCF is, what is the HCF? Highest common factor. HCF is, this is the highest common factor. 2 into no other common factors are here. So HCF is equal to 2. HCF is equal to 2. Then find the LCM. How we can find out the LCM? 5 ones LCM 92, 510, 2, 46, 255. What is the LCM? Least common multiple. least common multiples. Then check with another number, that is again 2. 2, that is 23. 23 to 55. Again the next prime factor 255. 3, 23. 253, 85. Again with 5. 23, 17. So LCM. LCM is equal to 2 into 2 into 3 into 5 into 23 into 17. You multiply with these numbers, you will get 23460. This is the LCM 23460. When multiply with this, yes. What is HCF into? Therefore, HCF into LCM is equal to this HCF into 23460. HCF into LCM 460, that is 46920. 2 into 23,460 is equal to 2 into 0, 2, yes, correct, 46,920. Then what are the product of the numbers? Product of numbers. Product of numbers is equal to how much? That is 92 into 510. You multiply 92 with 510, you will get the product of numbers 0, 2, 9, 6, 4. Yes, correct. Both are same. 46,920. 46,920. On verification we get both are same. LCM into HCF is equal to product of the given numbers. Okay. അടുത്ത ക്വസ്റ്റ്യൻ നോക്കാം. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ try for next question. Find the LCM and HCF. You write find the LCM and HCF of the integers 12, 15 and 21. Here there exists three integers 12, 15 and 21. First you try for HCF. 12 can be 2 into 2 into 3. 15 can be 5 into 3. 15 can be 3 into 5. 3 into 5. 21 can be 3 into 7. This is the highest common factor. HCF. HCF is equal to 3. LCM. Try for LCM. LCM 12, 15, 12, 15, 21. First with 2, 6, 15, 21. With 3, 2, 5, 7. These are prime numbers. So LCM. LCM is 2 into 3 into 2 into 5 into 7. No other common factors. 2 into 3 into 2 into 5 into 7. That is LCM. LCM is equal to 2 into 3, 6. 6 into 2, 12 into 5, 60. 60 into 7, that is 420. So, HCF into LCM, that is 3 into 420, 0, 1260, 1260. Then this is LCM into HCF. And product of the numbers, product 12 into 15 into 21. That is again 1260. In the question, there is no need to test whether it is equal or not. In the question that is in NCERT book, the question is find the LCM and HCF of the integers 12, 15 and 21. That's only. It's the previous question also. CBSE previous question 2020 question. Okay. Another question. So once again, you remember this equation from the first page. Important points to remember. HCF of AB into LCM of AB is equal to A into B. HCF of AB is equal to, if we take HCF of AB, take this into right hand side, A into B divided by LCM of AB. Similarly, LCM of AB is equal to A into B divided by HCF of AB. Okay, you have to remember these very important three formulae. Very important three formulae. Okay, you can expect questions from this section using this formula in your CBSE examinations. Okay, one more question. Given that HCF of 306, HCF of 306, comma 657 equal to 9. That is given, equal to 9. And find LCM of 306, 657. Find LCM of 306, 657. So use this third formula. What is LCM of AB? LCM of A comma B is equal to A into B divided by HCF of A comma B. This is the formula. Here what is A? This is A, this is B. Okay, that is therefore LCM of 306, comma 657 is equal to 306 into 657 divided by HCF of AB. This is HCF of AB. That is given as 9. 306 into 657 divided by 9. That is equal to how much? This is equal to, we can cancel with 306. 306 with 9. What is 306? 9 in 306, that is 34 times. 34 into 657. 9, we can cancel 9 with 306, that is This is 34 times 9 into 4, 36, remainder is 3. 9 into 3, 27, it's correct. 34 into 650. This is it again. 34 into 657. You multiply 34 with 657, that is equal to 4 into 7, that is 8, 3, 3, 22,338. 22,338. This is the answer. So LCM of 306, 657 is equal to, this is the answer. Okay, right? Now I can give some homeworks for you, and the next class we again continue this chapter, some homeworks. Express each number as a product of its prime factors. Question 5005. Question, express the number as a product of its prime factors. Question 5005. Another question. Find the LCM and HCF of the pair of integers 336 and 54. 336 and 54. And also verify that HCF into LCM is equal to product of the two numbers. Product of the two numbers. Do these questions as homeworks. Okay, once again, we can conclude our today's class. In today's class, we discussed about the fact that the important points to remember: HCF of AB into LCM of AB, that is equal to A into B. That's mean. What's its meaning? The LCM, the product of LCM and HCF of any two real numbers, not real numbers, any two integers, that is equal to product of the integers. And again, we get two more equations from this equation, that is, if we have to find HCF of B, HCF of AB, we can take the equation as like this: A into B divided by LCM of AB. Similarly, LCM of AB is equal to A into B divided by HCF of AB. So it is very, very important section in this chapter. You can expect the questions in your board exams from this section. Okay. One more important result: HCF of AB is equal to 1, where the only when if AB are co-prime numbers, co-prime integers. Okay, right? Then again we discussed with the different system of numbers. That is, what are the system of numbers? The important system of numbers are natural numbers. Already we had discussed it. Whole numbers, we discussed it. Rational numbers, we discussed it. And irrational numbers, we discussed it. Then finally we discussed it, real numbers. Real numbers means the set of, or the collection of, or the group of rational numbers, and irrational numbers which are includes all integers, that is positive or negative integers. Integer means the positive integers means natural numbers also. Natural numbers are also called counting numbers. If the integer 0, if the integer 0 is added with natural numbers, we can say that the system is called whole number system, whole numbers. It is usually denoted by W. Natural numbers are usually denoted by N. Z or I represent for integers, and capital R, it is used to represent real numbers. Then examples for rational numbers and irrational numbers. And another irrational number, pi. Pi is an irrational number, that is 3.14, etc. It is never end. Such type of numbers are called irrational numbers. Root 2, approximate value 1414, etc., 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 never ends. Root 3, 1.732, etc., etc., never ends. Such numbers, such type of numbers are called irrational numbers. I know you are already studied about in your lower classes this type of numbers, etc. Okay, right? It's called irrational numbers. If the number is not rational, then it is called irrational numbers. That is the definition of irrational numbers. Real numbers means the real number system contains the group or the set of all or the collection of all rational numbers and irrational numbers. Okay, well, in the next section we have discussed divisibility. Already you know about it. Then this is another most important part of this chapter, fundamental theorem of arithmetic. The theorem is very important. What is the fundamental theorem of arithmetic? Every composite number can be expressed as a product of its prime factors. That is called fundamental theorem of arithmetic. Okay, right? Today we are going to discuss some problems from NCERT book. Almost all questions are previous year board exam questions. Yesterday means the last class, we discussed the theory part of this chapter, and already we have done some simple questions also. Okay, our first question, check whether it is a previous year question. Check whether 6 raised to n can end with 6 raised to n can end with the digit 0 for any natural number n. That means 6 raised to 1, 6 square, 6 cube, 6 raised to 4, 6 raised to 5, etc. We have to check whether these numbers are end with the digit 0. Check whether. So, look here, already I have given the solution. If the number 6 raised to n for any natural number n ends with the digit 0, then it will be divisible by 5. If every natural number, if it is end with 0, that strictly divisible by 5. Strictly divisible by 5. That is the prime factorization of 6 raised to n would contain the prime factor 5. But 6 is equal to 2 into 3. There is no such a factor 5. That is, doesn't include here. 6 is equal to 2 into 3 only, or 1 into 6, or 2 into 3. So, 5 doesn't include here. Only 2 and 3 includes. So, 6 raised to n can be 2 into 3 whole raised to n. 6 is equal to 2 into 3. So, 6 raised to n, what is 6 raised to n? 2 into 3 whole raised to n. That is equal to 2 raised to n into 3 raised to n. Why? AB whole raised to n is equal to A raised to n into B raised to n formula. So 2 into 3 whole raised to n, 2 raised to n into 3 raised to n. The only prime is the factorization of 6 raised to n. They are 2 and 3 only. So there is no natural number n for which 6 raised to n, that is n's with the digit 0. If it is n with the digit 0, that must be divisible by 5. But it is not here. 5 is not here. 5 is not a factor of 6. 5 is not a factor of 6. So 6 raised to n, never n with 0. If it is 6 raised to 1 or 6 square, 6 cube, 6 raised to 10, etc., 6 raised to 100, etc., but never end with the digit 0, because the only factor of 6 is 2 and 3 only. If a number ends with 0, that must be divisible by 5. That is the reason. Okay, right? It's the previous question. Solution is also here. Then our next question. Explain why 7 into 11 into 13 plus 13 is a composite number. It is also a previous question. What do you mean by composite number? Composite number means 4 is a composite number, 6 is a composite number, 9 is a composite number. We can factorize it into other prime factors. That is, 4 can be 2 into 2, 6 can be 2 into 3, 9 can be 3 into 3, etc. These are called composite numbers. Prime numbers means 2 is a prime number, 3 is a prime number, 5 is a prime number. For a prime number, 1 and the same number only, they are the factors of the prime number. But composite number, other than that, so many factors arise. Okay, they are called composite numbers. Okay. Explain why 7 into 11 to 13 plus 13 is a composite number. Look here. 7 into 11 to 13 plus 13. That is 7 into 11, 77. Into 13 plus 13. Here, 13 is the common factor. That is 77, take 13 into outside. So 77 plus here it is 1. That is 77 plus 1 into 13. 77 plus 1 is 38. 38 into 13. That is, we can factorize it 78. 2 into 3 into 70. How we can factorize it? 78. This is 78. How we can factorize 2 and 39. 2 and 39. Then again we can factorize. What is 39? 3 into 13. 3 into 13. This is called factor tree. This is called factor tree of 78. This is called factor tree. 78 is factorized into first take 2 and 2 into 39. Again 39 can be 3 into 13. So 3 into 13 in the reverse order, 3 into 13 is 39. Again 2 into 39 is 78. Okay. This is a method of creating factor tree of a number. Okay. That is 78 into 13. Again 78 can be factorized into 2 into 3 into 13. These are the factors. 2 into 3 into 13. 2 into 3 into 13. Into this 13. Into this 13. 2 into 3 into 13 into this 13. Okay, that means 2 into 3 into 13 square. 13 into 13 is 13 square. Okay, full stop. Since 7 into 11 plus 13 can be expressed as a product of prime, it is a composite number. So this number consists so many factors. 2 into 3 into 13 into 30. That means 13 square. So clearly it is a composite number. So clearly it is a composite number. A prime number can be expressed as only 1 into that number. For example, 13 is a prime number. This can be factorized into 1 into 13 only. No other factors are there. This type of numbers are called prime numbers. But this number is expressed into so many product of so many factors other than 1 and that number. They are called, such type of numbers are called composite number. So it is clearly it is a composite number. Okay. This is called a factor tree. Okay. Yeah, in the last class we factorize so many questions we have done the factors, how to find out the factors. In this method, this is called factor tree method. Just like the branches of tree, it is increasing like that. Okay. Then, okay, another question. Find the values of x, y, and z in the following factor tree. This is the factor tree. Can you visible the board? Again, I can draw this like, suppose this is x, factors of x. This is 2, this is y, and again from y to z, and again from z to, that is 17. Okay, we have to find out the values of x, y, and z for completing this factor tree. Z is the product of 2 and 17 because it is given that we can start with the bottom, not from upper top level. Always you start from bottom. So Z can be 2 into 17 because 2 and 17 are the factors of Z. So Z is equal to 2 into 17, that is 34. That is 34. So in the place of Z is what? 34. Then what is y? Y means 2 into Z. Y is equal to 2 Z. Y is equal to Z. That is 2 into what is Z? 34, that is 68. Y is equal to 68. X is equal to what is x? X is equal to 2 into y. X is equal to 2 into y. So this is equal to 2 into what is y? Already we got it, that is 68. 2 into 68 equal to 136. 136. This is the values of x, y, and z. You always start with bottom to top, not from top to bottom in this type of question. Okay, right? Okay. The solution is already here. 136. 136. Or we can x we can find out. You just take the product of this shortcut method. 2 into 2 into 2 into 17. That is x. Okay. What is y? Direct shortcut method. X is equal to 2 into 2 into 2 into 17. What is y? Y is equal to 2 into 2 into 17. What is z? 2 into 17. This is the shortcut method. This is the basic concept. This is the fundamental concept. And this is the shortcut. 2 into 2 into 2 into 7. That is x. What is y? Y is, you start from here, 2 into 2 into 70. What is z? You start from here, 2 into 70. That is another method. Okay. Complete the following factor tree and find the composite number. Okay. I can give you the factor tree. Factor tree is, that is x, and also given this is 2, this is not given, and again 3, that is given, this is not given, and again this is 7 and this is 161. Again, this is 7. This is not given. We have to find out x. Okay. Actually, we can start with the bottom level. 161 is the product of 7 and this box. Then what will be this box? 161 by 7. 161 by 7. So how much? 716 2 times 14. 21 3 times. 7 into 23 is 161. Then what will be this box? 7 into 161. 7 into 1, 7. 1127. 7 into 1, 7. 42 remainder 4. 7 plus 4, 11. Okay. Then what is this box? 3 into this. That is 3381. 3381. Then what will be x? We have to find out the value of x. Complete the following factor tree and find the composite number x. Composite x. What is composite number? This can be 2 into 3 into 7 into 7 into 23. That is one method. Or directly you can find out 2 into what is x? X is equal to 2 into 3000 and 381. That is 267. 2 into 1, 2. 2 into 8, 16. Remainder 1. Then 7. Okay. 6762. This is the answer. Another method is we can find out from here 2 into 3 into 7 into 7 into 23. No problem. Okay. Yes. Next question. Yes. Then again, we are going to irrational numbers. In the last class, we discussed about irrational numbers. What is an irrational number? Okay, revisiting irrational numbers. Important points. Once again, irrational number. A number, yes, is called an irrational number if it is not rational. The last class we discussed it. That is, it cannot be expressed in the form p by q. What is a rational number? Any number which can be expressed in the form p by q, but q not equal to 0. P and q are integers. It is called rational number. If it is not a rational number, it is an irrational number. Okay. That is integers and this is q. Notice that q not equal to 0. For example, the examples of rational numbers. The last class we discussed it. Root 2, root 3, not root 5, root 12, pi. Pi is an irrational number. Pi, that is 22 by 7, never-ending process. 3.14, etc., etc. It is a never-ending process. Such type of numbers are called irrational numbers. Okay. Second case. Root p. Root p is irrational where p is prime. Root p is irrational where p is prime. For example, root 2, root 3, root 5, root 7, root 11 are all irrationals. Next is sum, very, very important property. Sum or difference of a rational number and an irrational number is an irrational number. For example, 3 is a rational number. 3 is a rational number. 2 is an irrational number, right? It's a sum, 3 plus 2. It is also an irrational number. Irrational. And it's a difference, that is 3 minus root 2. That is also an irrational number. That is the condition 3. Sum or difference of a rational number and an irrational number is an irrational number. Okay, right? Next. Product or division of a non-zero rational and an irrational number is an irrational number. For example, 3 is a non-zero rational number, right? Root 2 is an irrational number. Its product 3 root 2. It is irrational. It is irrational. And 3 by root 2, it's a division. It is also irrational. Or root 2 by 3 is also an irrational number. That means sum or difference of a rational and an irrational number is irrational. Its difference is also an irrational number. A non-zero rational and an irrational number, its product is always irrational. Division is also irrational number. These are the main, very important properties of irrational numbers. Okay? You have to remember always these important points. Important points. Right? So why I am giving the name important points. Very, very important points regarding irrational numbers and at the same time rational numbers also. Okay, right. 0 is dash. 0 is a rational number. 0 is a rational number, right? All integers are rational numbers. We can express all integers as, for example, 2 is a rational number, negative 2 is a rational number. Why? 2 can be 2 by 1, minus 2 can be minus 2 by 1. Any number which can be expressed in the form p by q, where q not equal to 0, and p and q are integers, are called rational number. If it is not a rational number, that is called, they are called irrational numbers. Right? Clear? Okay. Now we can do some very, very important questions. Very, very important question. Almost every year in your board exams, this type of questions are asked. Prove that root 5 is irrational. I tagged the years in the board examination asked this question. CBSE 2014, not 2, 2016, 2017, 2019, 2020. Very, very important question. It can be the question, it can be root 5 or root 2 or root 3 or root 7 or root 8, etc., etc. All are same type questions. Here we are going to discuss root 5 is, prove that root 5 is irrational. Similar questions you can expect. Similar question means prove that root 2 is irrational, prove that root 3 is irrational, prove that root 5 is irrational. That is this question. Prove that root 7 is rational, etc., etc. Okay, right? Okay, how we can prove root 5 is an, already we have root 5 is an irrational number. How we can prove it? I can give you a theoretical proof. Look here. First, we take root 5 is a rational number. For proving root 5 is rational, we consider, let us consider it is a rational number. Then we will reach a contradiction. Okay, look here. Let us assume to the contrary that root 5 is rational. Okay, then if root 5 is rational, this can be expressed in the form a by b. That is the condition of or definition of a rational number, but b not equal to 0. And a and b are the coprime numbers. The coprime means the least, that is the least ratio. No other factors other than 1 for a and b. That means coprime numbers. So root 5 is equal to a by b when a and b are co-prime. That is HCF of AB is equal to 1 HCF. No other common factors are there. So you take b into left hand side. Root 5b is equal to a. We can take b into left hand side. Root 5b is equal to a. Squaring both sides. Root 5b square is equal to a square. Square of root 5, 5. Square of b square equal to a square. Take it as equation 2. This is equation 1. This is equation 2. Okay. 5b square is equal to a square means 5. What is 5? 5 is a multiple of a square. That is the meaning of 5b square is equal to a square. Or 5 divides a square. 5 divides a square. That is the meaning of 5b square equal to a square. 5 divides a square. But what is 5? 5 is we have 5 is a prime number. Therefore, 5 divides a also. 5 divides a also because 5b square is equal to a square. 5 divides 5 is a prime number. 5 is a prime number. 5 therefore 5 divides a also. That means we can express a in the multiple of 5. That is can be a equal to 5c. 5c means c is a arbitrary number. The meaning is a is a multiple of 5. That is the meaning of 5c. C can be D, E, F, no problem. The important fact that a is a multiple of 5. Why? What is the reason? 5 divides a also. 5 divides a also. For some integer, not same, for some integer. Okay. For some integer. Next, putting this, not putting this value of a into what is a equal to 5c, because 5 divides a also, a equal to 5c. Putting this value of a in equation 2, 5b square equal to what is a 5, that is 5c square. 5b square and 5a square, that is equal to 25. 5 into 5, 25c square. 25c square, that is, I can there is something wrong here. Look here, 5b square is equal to a square, that is equation 2. Put this value of a here, that is 5b square is equal to 5c square, that is 25c square. We can cancel the 5 with the 25, that is 5. That is b square equal to 5c square. B square is equal to 5c square. This means that 5 divides b square. 5 divides b square means, and so 5 divides b also. 5 divides b is also, because 5 is prime. If 5 divides b square, 5 also divides b also. Therefore, a and b have 5 as a common factor. Already we have 5 divides c, and from here we got 5 divides b also. That means a and b have 5 as a common factor. That is never possible, because already we take a and b have only one is the common factor. But from here we got a and b have 5, another common factor 5. That is a contradiction. That is a contradiction. But this contradicts our assumption. Already we assume that a and b have only one. One is the common factor, no other common factors, because they are co-prime numbers. But from here we got A and B have another common factor, that is 5, because 5 divides the A is the multiple of 5. We got here B is the multiple of 5. That means A and B have again there exists a common factor 5. This contradicts our assumption. Why? We assumed that, already we assumed that A and B are co-prime numbers because root 5 is a rational number. We assume that, not exact root 5 is a rational number, that is A by B. So our assumption is contradicts our assumption other than 1. Okay, that means our assumption is wrong. As our assumption is wrong means root 5 is rational is wrong. Then only possibility is there. If root 5 is not rational, then root 5 is an irrational number. This contradiction has arisen because of and the correct assumption that root 5 is rational. Hence root 5 is irrational. Root 5 is irrational. This contradicts our assumption. Okay, it's a very good question. You can expect this question as a type question. You have to write these arguments the same method. Okay, you can expect this question in your board exams. Very, very important question. Okay. Another question, prove that 3 plus 2 root 5 is irrational. 3 is a rational number, root 5 is an irrational number, sum of a rational and irrational number is irrational number. We have the property, already we have. Okay. In the same method we can do this question. Okay. Let us assume what will be our assumption? It is a rational number. Let us assume to the contrary that 3 plus 2 root 5 is rational. That is, we can find the co-prime integers A and B. B not equal to 0 such that B by A is equal to 3 plus 2 root 5. Because we take 3 plus 2 root 5 is a rational number. We have to prove it is an irrational number, but our assumption is 3 plus 2 root 5 is a rational number. So we can express every rational number can be in the form of B by A or A by B, no problem, or A by B or A by B or A by B, no problem, but B not equal to 0. Then take 3 into left hand side, that is B by A minus 3 is equal to 2 root 5. Then take the LCM. B is the LCM. A minus, just close. A minus 3B by is 2 root 5. Okay. Then take 2 into left hand side. A minus 3B by 2B is 0 root 5. Root 5 is an irrational number, right? A minus 3B by 2B. Then divide with 2B. A by 2B minus 3B by 2B equal to root 5. A by 2B minus here B cancelled the 3 by 2 equal to root 5. A by 2B is a rational number. 3 by 2 is a rational number. Difference of two rational numbers is always a rational number. Sum and difference of a rational number is always a rational number. But root 5 is irrational number. Already we know about it. So this assumption is wrong. A by 2B is a rational number. 3 by 2 is a rational number. Why A by 2B is a rational number? Why A by B is a rational number? So A by 2B is also a rational number. 3 by 2, that is 1.5, it is a rational number. Difference of two rational numbers are always a rational number. But root 5, what is root 5? We have root 5 is an irrational number. This contradicts our assumption. Okay. Since A and B are integers, therefore a by 2b is rational, and hence a minus 2b minus 3 by 2 is rational, and so root 5 is rational. But root 5 is irrational. We have root 5 is not rational. It is an irrational number. Clear? So, but there contradicts that fact that root 5 is irrational. This contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational. Already we assume that 3 plus 2 5 is rational. But from this result, it contradicts. Our assumption is wrong. No doubt it is wrong, because in the simplification we got that is root 5, but the left hand side is a rational number, right hand side is an irrational number. That is never possible, impossible. So our assumption is wrong. Our assumption is wrong. So 3 plus 2 root 5 is an irrational number. Very, very important question. Okay. And I can give another question, previous year question. These are some homeworks, same type. Prove that root 2 nearly 8 or 9 times asked this question in your board exams. Prove that root 2 is rational. Prove that 3 plus root 5 is an irrational number, very, very important. Find the HCF and LCM of 26, 65, 117 using prime factorization. You just do it as homework. Okay. I can give one more question. Prove that 1 by root 2, prove that 1 by root 2 is an irrational number. Is an irrational number. Prove that 1 by root 2 is an irrational number. Okay. Let us assume. Let us assume that 1 by root 2 is rational. You always use this method for doing this type of questions, rational number. So this can be expressed as, therefore 1 by root 2 can be expressed as in the form of a by b, where b not equal to 0. That is, root 2 is equal to b by a. Take the reciprocals on both sides. Since a and b are integers, A and B are integers, b by a is a rational number, then root 2 is also a rational number, because root 2 is b by a, because root 2 is equal to b by a. But already we have root 2 is an irrational number, but already we have root 2 is an irrational number, but b by a is a rational number. Root 2 is an irrational number, b by a is a rational number. Then how root 2 is equal to b by a? That is impossible. That is never possible. It contradicts our assumption. Our assumption is wrong. That is wrong. So it is very clear that root 2 is an irrational number. Root 2 is an irrational number. So conclude that. How we can conclude it? Since root 2 is an irrational number, its reciprocal is also an irrational number. reciprocal of an irrational number is irrational. Since root 2 is an irrational number, 1 by root 2 is also an irrational number. This is the proof. This is the proof. Okay. And one more question. Prove that prove that 6 plus root 2 is an irrational number. Prove that 6 plus root 2 is an irrational number. So let us assume 6 plus root 2 is let us assume 6 plus root 2 is rational. So we can express this as 6 plus root 2 equal to a by b because a by b is a rational number. A by b is a rational number. That is 6 minus a by b is equal to, or we can take root 2 equal to a by b minus 6. Root 2 is equal to a by 6b by b. A by a minus 6b, that is root 2 is equal to a by b minus 6b by b. B cut. Root 2 is equal to a by b minus 6. From this equation, it is very clear that how we can conclude our problem. A by b is a rational number. 6 is a rational number. Difference of two rational numbers are always rational. But already we have root 2 is an irrational number. Then how it is possible? Impossible. It is never possible. We can't equate a rational number and an irrational number. Root 2 is irrational. A by b minus 6 is rational. So this equation contradicts again our assumption because a by b minus 6 is rational, but root 2 is an irrational number. This is never possible. That is not possible. That is impossible. So it is very clear that 6 plus root 2 is an irrational number. Clear, my students? Okay. Our theory section, NCERT book is almost completed. This chapter, first chapter, that is what is our first chapter? Real number system or real numbers. This chapter is completed. Almost all questions we have discussed it. Type of questions we have discussed. Okay, in the next class, we will discuss some MCQs, multiple choice questions from this chapter. The next class we will discuss some multiple choice questions, MCQs from this chapter. Okay, the theory topics and other subjective questions are completed. Okay, the next class we will discuss multiple choice questions. The short form is MCQs, MCQ. MCQ, multiple choice questions. Multiple choice question means a question with 4 options are there. Only one is the correct answer. We have to check. We have to choose the correct answer. We have to choose. We have to identify the correct answer. How we can identify the correct answer? We will do in the next class such type of questions. Subjective questions are almost completed. Dear students, thank you. See you again next class. Thank you. Thank you all.